Hey guys, you're gonna start with Lauren here. Couple things I wanna get started. This is our fourth class, so I just wanna remind you guys a few things, especially when you're working with Lauren or Alexa. When please ask questions, okay? And it becomes hard for us, for Lauren or even for Alexa, when they wait and nobody asks questions. So what I've told for Lauren from today onwards is to give a pause, take a pause so that people have the times, and don't hesitate to ask her to repeat things. Okay, so for example, today she's going to be working with math, and let's say you guys need her to explain it again. Ask. Nobody's mind readers, right? So, especially online students, I really want you guys to say, "Hey, Lauren, can we can we can you repeat this? Can you explain this again? Maybe use another method to explain, but be explicit. Don't hold back." Make sense? So I'm definitely wanted to make sure that the online students hear this, because we do not want your questions not answered. We want your questions answered right away. And repeat things. Repeat. So I know. And if you're not comfortable, reach out to Lauren separately as well, outside the class. I'm more than willing. I'm sure she will be more than willing to help you guys. And if Lauren is going fast, don't wait. Just say, "Hey, Lauren, can we slow down?" This is, again, I keep telling you, this is not high school system, right? This is a professional setting, and I'm pretty sure she won't mind. I won't mind if you say, "Hey, Manoj, can we slow down?" I won't mind. It's a good thing that we want you to learn, but it will be hard for us if we don't say things. And I can assure you guys that answering your questions is our highest priority. Am I making myself clear on this? Online students, is that clear?
Yes.
Okay.
Yes.
And interact with her. And Lauren, this is how I sit so that they can see me. And I would just say, I'm gonna wait 30 seconds. Just wait so that they can actually ask you the questions. But make sure to ask questions. Learn. Okay. Reading is tricky. Let me tell you, teaching reading is like asking somebody to train how to smell. It's tough. Like you just smell, right? There's no training for it. So reading is tough, but you still can really work hard on this. You with me on this? Every question matters. Everything here matters. So don't hold back on asking questions. I know with me, I don't see any issues because I think you guys been asking a lot of questions. But I do not know with Lauren and even Alexa starting next week. Sounds fair? Online students, you guys good?
Yes.
And no
Yes.
and no question is a dumb question, and no question is a stupid questions. I can't stress enough on that part. Okay, so just be honest. Just be friendly. Just be casual about it. Okay, no, this, for example, hey, today she's doing triangles. Let's say she did the area of a triangle problem, and let's say you don't understand. Oh my God, this is so simple. How should I ask this question? What will others think of me? I don't care about that. I care about whether you learned it or not. So, and I can tell you, according to our plan, we are going according to our plan. We are very well set. So we are not behind or anything like that. Fair enough, Lauren? So let's interact. I would like to have more interaction with, not just with me, with Lauren and Alexa, so that you guys can have fun. All right? But without that, we don't do justice. All right? See you later. I'll see you at 7:30. See you later.
Okay, so like you mentioned, we're going to be doing math today. So if you guys have your math packets that Manoj gave you, we're going to be reviewing a little bit of what we did last time on page 2 of the math packet. And then we'll also be moving on to page 3 and then talking about like triangles. If we have time, we'll move on to circles, but things like that. So if you guys have your math packets, you want to flip to page 2. And then before we start with the review, did you guys have any questions about the math we did last week? You have a question?
Yeah, so I have a question. So the math on the ACT, is it, what kind of math is in it? So there's geometry, and there's elementary or elementary like math. But like, what other math is there? Like algebra 2, trigonometry. Like, what else is in there?
Yeah, it's a little bit of each. They do have some algebra 2, some trigonometry. I don't know the exact breakdown. I can figure it out and get back to you.
Okay.
But I know there's like more of some types of math, like more of geometry than of like elementary algebra.
Okay.
And it's just because like as you guys like take like more classes and you like go up in grades, those classes should help you prepare further for like the ACT. So like for someone who's taken just geometry maybe, and then versus someone who's like taken like pre-calc, they might like know more of the math that's on the ACT just because they've taken that class.
Okay.
So yeah, I can find out the exact breakdown and I'll let you guys know next week. I'll write myself a note. But yeah, I'll figure out the breakdown for you.
Alright, thanks.
Okay, any other questions before we start? Alright, so math, or page 2 of this math packet. And then, like I said, we're going to be doing a review. So first we're going to review the parallel lines we talked about and then those different angle relationships. So I'm going to draw a picture up on the board. Okay, so here are my 2 parallel lines. Then we talked about the line that crosses through it being called the transversal. So if I label these. Okay. So we talked about 4 different types of relationship pairs. We had the corresponding angles. So on this drawing, my corresponding angles could be angle 2 and then angle 6. And that's just because they're in like the same spot in reference to the lines in the transversal. But not just 2 and 6. I could also say like 1 and 5, 4 and 8, or 3 and 7. Those would all be corresponding angles. And then we also talked about the alternate interior angles. So for that one, I could choose angle 4 and angle 6. And so for those ones, they're alternate, which means they're on opposite sides of the transversal, but then they're also on the inside of my entire figure. And then 5 and 3 would be another pair of alternate interior angles. And then lastly, we have the alternate exterior angles. So those ones, again, are on opposite sides of the transversal. And then they're kind of on the exterior of my figure. So that could be 2 and 8. And then I could also say angles 1 and 7 are alternate exterior. So these 3 we just talked about, corresponding, alternate interior, and then alternate exterior. All of these pairs of angles are congruent. And so they're not congruent to each other, but if I have a pair of corresponding angles, they're congruent. If I have a pair of alternate interior angles, they're congruent. And then if I have a pair of alternate exterior angles, those are like congruent to each other. Okay, any questions so far? And then there was one more angle pair that we talked about, and those are consecutive interior. So for that one, I could say either angles 3 and 6, or 4 and 5. And so they're consecutive, kind of, you can think like they're like come right after each other, like they're right next to each other, and then they're also on the inside of our figure. And then there's no such thing as consecutive exterior. I'm not really sure, maybe because they're like they don't come right after each other. But yeah, so there's just the 4 types, and then consecutive interior is the last one. The thing about these ones is that they are supplementary. So that's also a word I mentioned last week. Okay, That's also a word I mentioned last week, and that means that the two angles have a sum of 180 degrees. And so none of my angle pairs are this term, but we also talked about complementary angles, which meant that they added up to 90 degrees. That doesn't relate to any of the angles we just talked about, but that's just another vocab term. Okay. Do you guys have any questions about this? No? Anyone online? Okay, so hopefully you guys have notes down, or you can look at your packet, but we're going to do just like a practice with these different types of angle pairs. Okay. Okay, so I've got my figure here. Lines L and lines M are parallel, and so we can know that by this little symbol, that little kind of like caret thing. That shows me that the two lines are parallel. And then I've got two transversals actually in this figure. So one's crossing straight through. That's supposed, sorry about my drawings, it should be like a straight line if it kind of looks like it. And then this one is a little bit diagonal, and that's another transversal that's crossing through my two parallel lines. So if I were to tell you guys that the measurement of angle 9 is 80 degrees, and that the measurement of angle 5 is 68 degrees, we should be able to find pretty much every single other angle in this figure. So let's start. Let's say, what if I asked you guys what angle 12 was? So angle 12 is right here. And then what we know is that angle 9 is 80 degrees and that angle 5 is 68 degrees. Well, angle 5 is like all the way over here. It doesn't really have a relationship maybe to angle 12. But angle 9 is right on the other side of that line. So remember when I told you guys that if there's like a straight line, and usually they don't try and trick you. If it looks like a straight line, it's probably a straight line. So if we have two angles that are separated and they form a straight line, they're going to be supplementary, which means they add up to 180. So 9 and 12, those two angles are forming my straight line right here. So we know that 9 and 12 are supplementary angles. And so that means that they add up to 180 degrees. If we know that angle 9 is 80 degrees, we should be able to find 12. So I'm going to name 12x and then 9y. Or actually, I don't need to name it y. But let's say if angle 12 is x plus, and then angle 9 is 80 degrees, 80, that should add up to 180 degrees. And then from there, we can find angle 12 by just subtracting 80 from both sides. So x is equal to 100, and then remember x represented angle 12, so the measurement of angle 12 is actually 100. So if they give you this figure and they ask you what angle 12 was, by giving you this information, you should be able to figure out that it's 100 degrees. Okay, did that kind of make sense? Yep. Okay, so I'll leave that up here. But what if I ask you guys, what's the measure of angle 4? So angle 4 is right here. And so we know angle 9 is 80. We know angle 5 is 68, but we also just figured out that angle 12 is 100. So using what we know, can you guys figure out like what the measurement of angle 4 would be? Does someone want to yell it out?
80 degrees.
112?
Not quite.
100 degrees.
Yep, it'll be 100 degrees. And so there's like a couple different ways we can figure it out. But remember we talked about corresponding angles are congruent. 12 and 4 are corresponding because they're two parallel lines cut by the same transversal. So they should be the same measurement. So we can figure out that it's 100 degrees from that way. Or we can base it off of, we knew about angle 9 being 80. We can say, well, if 9 is 80 degrees, then 1 is also 80 degrees. And 1 and 4 are supplementary, so we can do what we did here, subtract 80 and figure out that 4 is 100 degrees. So with parallel lines, there are like a couple different ways to figure out each angle. Usually there's more than one, but yeah, 4 and 12 are congruent, so they're both 100 degrees. Okay. Let's see. What if I asked you guys what's the measurement of angle 7 using what we know?
And measure angle 7 is it's vertical angles with measure of angle 5, and measure of angle 5 is 68 degrees. So that would make the measure of angle 7 68 degrees.
Yep. Did you guys online hear that? How he explained it?
No.
No? Okay. So I'll kind of repeat what he said, but he said that the measure of angle 7 is 68 degrees. And so the reason for that is that 5 and 7 are vertical angles. I think I forgot to mention it today, but I did talk about it last week. And vertical angles are also congruent, if you want to make a note. So vertical angles were those ones that were opposite of each other. But 5 and 7 are vertical angles, so that means they're the same measurement. We do know angle 5 because I gave it to you, it's 68, so that means 7 should also be 68 degrees. Okay, last one. Can you guys tell me the measure of angle 16? Does someone want to give the answer?
120.
Yep. 100. Sorry, you want to say it? You can go ahead.
Never mind, I was wrong.
Oh, okay. Well, angle 16 is, let me fix this. Angle 16 is 112 degrees. And so how we knew that is we know that the angle, or the measure of angle 5 is 68 degrees. Well, angle 5 and angle 13 are corresponding angles, which means they're congruent. And so then we can do kind of that equation we set up earlier. We can say, if I were to name angle 16x, I could say x plus 68 is equal to 180. And then to find out what angle 16 is, I would subtract 68. And then 180 minus 68 is 112 degrees. So there's, I guess, that was one way you could figure it out. There are multiple. So I could also say maybe that angle 5 and angle 7 are vertical angles. And so angle 7 would be 68 degrees. And then we talked about the consecutive interior angles being supplementary. So that would mean that 68, or angle 7 plus angle 16 should add up to 180, and then we can do the same equation to get 112. Okay, do you guys have any questions about that? Does anyone still need the notes up here? All right. Okay, so I'm gonna draw a problem that maybe you could possibly, you won't see this one, but you could see something like it on the ACT math. Okay, so let me get the questions here. Okay, so the question here is to find the value of the variables in in the figure. So if you guys were taking this as an actual test, it would be multiple choice, but we're gonna solve for the answer. We're not gonna have 5 different options. So here I have a trapezoid, but you'll notice that my first base and my second base, they're parallel lines. And then this line right here is kind of acting as a transversal along with this line on the side. So I've got my 2 parallel lines and I have 2 transversals. And it's kind of like the figure before, but they maybe like erase the extra lines that were on the outside. So the question here is to find the value of the variables in the figure, which would be x and y. So if these 2 are parallel lines, we can actually solve for x and we can solve for y by setting up 2 different equations. So first I'm going to try and solve for, let's say we're solving for y. Well, what we know is that these are 2 parallel lines being split by a transversal. So this angle right here and then that angle right there are kind of acting as consecutive interior angles. And we know that consecutive interior angles are supplementary. So if I were to set up an equation, I would add this angle and that angle together and then set it equal to 180. So I'm going to write it like this. 90 plus 3y plus 18 is equal to 180. So hopefully you guys have your calculators. And if you don't have one, that's okay. You should still be able to solve without it, but we're gonna get y alone. So first I'm gonna subtract, I'll just type it in my calculator. So if we want to get y alone, we're gonna subtract 90 and we're gonna subtract 18 from the left side to leave us with 3y is equal to 72. You guys agree?
Yeah.
Alright, and then from there to get y alone, we want to divide by 3 on both sides so that the 3's will cancel out. So that should leave us with y is equal to 24. Is that what you guys got?
Yep.
Could you also set that equal to 90? And then, because you'd get 24 too.
Yeah, that's a good point. So, we know that this top angle is 90, so that means this bottom angle is 90. So if I just wanted to, I'll write it over here. If I just wanted to write my equation like this, 3y plus 18 is equal to 90, I could do the same exact steps, like subtract 18, divide by 3, and get 24 for y. So so this example and the ones we did before I was showing you, there's multiple ways to like solve for maybe like a variable or a certain angle. There's definitely more than one way to solve for it. So the way that works for you is the way that's going to work like best. Okay, so we know that y is 24. Does anyone have any questions about how we got there? Okay, so Oh, did someone say? No, I don't think so. Okay, so if there are no questions, we're gonna solve for x. So does anyone have a guess about how we could solve for x?
So I did.
What are you saying?
I was gonna say add them together and set them equal to 180.
Yeah, so the way we're going to solve for x is to add this angle and this angle together and set them equal to 180. So I'm going to write that up here. 15x plus 30 plus 10x is equal to 180. So to start, I'm going to combine my like terms. 15x plus 10x is 25x. And then I'm going to skip a step, but I'm going to subtract 30 at the same time. So 180 minus 30 is 150. Okay, and so last step to get x alone, we're going to divide by 25 on both sides. And so for x, you should get 6. You guys agree?
Yep.
Yeah? Okay. So if you were given this like question on the ACT, you should be able to solve for both y and x. Because we know that the parallel lines and we know our angle relationships. Okay, you guys have this all written down? Yeah. Yeah, everyone good? Alright, so next thing we're going to do, we kind of talked about this I'm not sure if we even did any practice problems, but we're going to talk about like finding the perimeter of just like certain shapes. So it is on page 2 of your math packet. Under quadrilaterals, it talks about, it just says for a square and a rectangle, the perimeter of a square, oh my gosh, okay. The perimeter of a square is 4 times the length, and then the perimeter of a rectangle is 2 times the length plus 2 times the width. So basically, to find the perimeter, you're going to add all the sides together. That's kind of what it's describing there in the notes. And so, yeah. So I'll kind of draw. So if I had a square, and then all the sides have a length of 2, you could say like 2 plus 2 plus 2 plus 2 is 8. Or like in the math packet, because it's a square, you can do 4 times just one of the side lengths. So 4 times 2, and you get 8. And then they also talk about a rectangle. So let me draw a rectangle. So let's say not that. Okay, let's say I have a width of 4 and then a length of 2. So we could do like the 2 plus 2 plus 4 plus 4 and get 12. Or we could do that equation in your math packet. 2 times the length, so my length was 2, plus 2 times the width. And that would be 4 plus 8, again, is equal to 12. So in a square or a rectangle, there's like 2 different ways to find the perimeter. And then when I'm taking like the math ACT portion, I never see them give you just like a square and say find the perimeter. They're going to give you kind of like a random looking shape. So we're going to practice that. have my shape here, and it's not exactly drawn to scale. Sorry. But the top, they told us this top length is 9 inches, side is 9 inches. They didn't tell us this part. We know that vertical part is 4 inches, and then this is 5 inches. They didn't tell us this part either. So basically, we're missing 2 parts of the side lengths of our shape, and we need to know them if we're going to find the perimeter. So actually, they do give us enough information to figure this out. So there's this. But because this isn't just a square or isn't just a rectangle, there's no set equation to find the perimeter. So my strategy is just kind of to add all the sides together. So we know this first side is 9. This bottom side is also 9. Or sorry, this side is 9. Plus, and then the bottom is what we don't know. So we can figure it out. We know that if there were like a imaginary line here, let's say this side length went all the way from here to there. Well, then it would be 9 inches because our top side length is 9 inches. So if we know that the total is 9, but we're actually missing 5, that should tell us that 9 minus 5, that should tell us that this side length, the part we actually do have, is 4 inches. Does that make sense how I got there? Okay, so now we know the bottom is 4 inches. We can add that to our equation. So 4, okay, plus, they told us this is 4. They told us this is 5. And then we've got one more side length to figure out. We'll do the same strategy. So we know this whole side is 4. Or sorry, we know this whole side is 9. We're missing 4. So what's left should be 9 minus 4, which is 5. So then 5 is our last missing side, and we'll add those all together. Does someone want to yell out an answer?
36.
Yep. So if you add all of those together, you should get 36, and then inches. You guys have any questions about that? Okay. So I'm going to draw one up here for you guys to do on your own, and then we'll go over it after. Okay, so here's the figure. 7 is that one that's kind of going horizontal, and then 6 is the vertical one, just to make sure. But I want you guys to find the perimeter of this shape. Okay, let's start going over this one. So if I were to find the perimeter, again, I'd add all the sides together. So we know the top of the shape is 16. That right side is 12. And then the bottom is what we don't know. So we know that the total is 16 inches because it's going to be the same as up top. And if we were to do 16 minus 7, that little part that's missing, you should get 9 inches for down here at the bottom. So I'm going to add that to my equation. We know the side is 6. We know that part is 7. And then we're also missing the left side. So if I were to draw like my imaginary line, this whole total should be 12 inches. We're missing that little 6-inch part down here. So then this part should be 12 minus 6. This is also 6 inches. Okay, so if I were to add those all together, you should get 56 inches for the perimeter. You guys agree? Yeah? Okay. So any questions about how we found this perimeter? Okay, next we're going to move on to area. So again, if you want to look at your math packets, it kind of lays out how to find the area of a square, the area of a rectangle, and then of a parallelogram and a rhombus. And again, this is on page 2 of your math packet under quadrilaterals. But so if I give you a square, kind of like what we did before, and let's say the side length is 2. To find the area of a square, like it says in there, it's use an L. So the length of a side squared. So it would be 2 squared, and that equals 4. And then let's say the side lengths were 2 inches. So once I plug this into my area equation, the label is inches squared. For a rectangle, we use the one we had before. The equation to find the area of this rectangle is length times width. We know the length is 2, the width is 4. So 4 times 2, you should get an area of 8. And say those were inches. My label would be 8 inches squared. So this was area of a rectangle. And then over here was the area of a square. So we're going to do a couple of examples, and then I'll give you guys some to do on your own. Okay, so let's say the question is, find the area of this shape. Well, they don't tell us what the shape is, but we know it's a square because all the side lengths are equal, and then all of the angles are 90 degrees. So that means it's going to be a square. So our equation for the area of a square was the side length, or just one side squared. And they told us one side is 41 inches. So we're going to plug that into our equation. 41 squared. And then does someone want to yell out the answer or just like call it out?
1,681.
So what you should have gotten for the area is 1,681, and then our label would be inches squared. I don't think they'll try and trick you on the ACT by putting like different labels. They won't just put like inches and have that as an answer choice, or like inches cubed. Usually all of the answer choices, there'll be different numbers, but they will all be squared. So you'll know like you're dealing with area. Okay, let's try this shape. Okay. So we've got another shape. And then the question is to find the area. Well, they didn't tell us what it is, but we know that it's a rectangle because although all the sides are 90-degree angles, we only have 2 pairs of congruent sides. So that means it's going to be a rectangle if you see that. So our equation for area of a rectangle was length times width. We know width is 21 feet and then the length is 45 feet. So if we were to multiply those together, we should get what?
145.
Sorry, what did you say?
Oh, 945, sorry.
Yeah, 945 should be the area. And then feet squared. Okay, any questions about this so far? So, I think, yeah, it's also laid out in your math packet, but we're going to talk about finding the area of a rhombus. Okay, I'm going to try and draw one up here. But the area of a rhombus is base times height. So let's say. Okay, here's my first rhombus example. And so for these ones, you got 2 pairs of congruent sides. And so our area equation for a rhombus is base times height. So even though it's kind of like, our base isn't on the bottom for this one, but it's kind of like on the side. So here's going to be our base, 56 yards, and then our height is 32 yards. So if we were to plug that into an equation, to our equation, 32 times 56, what would you get for the area of that rhombus?
1,792.
Yeah, so we said 1,792, and then the label is yards squared. So I'm going to draw another one off to this side. Hopefully you guys can see it. Okay. Hopefully you guys can all see that, but way over on the far left, I have another rhombus, and so the bottom has a measure of 7 inches, and then the height is 10 inches. So knowing that, can you guys find the area of that rhombus?
70 inches squared.
Yep. So the answer would be 70 inches squared. And so what we did was base times height, 7 times 10 to get us 70 inches squared. So this is not the only equation to find the area of a rhombus. Sometimes they'll give you the diagonals of a rhombus and ask you to find the area. So this is again in your math packet. But another way to find the area of a rhombus would be diagonal 1 times diagonal 2 divided by 2. So that's the second equation. So let me draw a rhombus here. Okay, so here's another rhombus, and then I've kind of like sketched out the diagonals. I didn't want to write it on the inside, so I wrote it out here. But this long diagonal has a length of 8 yards, and then the shorter one, kind of crossing horizontal, has a length of 2 yards. So we can find this area by plugging it into our equation. So I'm going to do, and it doesn't matter which one comes first, but I'll just do 8 times 2 divided by 2. Well, 8 times 2 is 16, and then half of that is 8. So even though we didn't use base and height, it's still going to be, our label is still going to be yards squared for the area of that rhombus. Does anyone have any questions about that type of equation? Alright, so I'm going to use the same rhombus, but we're going to use different numbers. So let's say that one side length is 18 inches, and then, or sorry, one diagonal is 18 inches, and then the other one is 8 inches. Can you guys find me the area of that rhombus? Yeah, so we had an answer, and it's 72 inches squared. So what you do is 18 times 8 divided by 2, and then you should get 72. Okay.
I have a quick question.
Yeah, what's the question?
So how do you know when to do like the B times H, or then when to do like the D1 times D2 divided by 2?
So it's kind of like which rhombus they'll give you. Sometimes they'll give you a rhombus and they'll show you like, maybe they'll tell you this side length, and then they'll tell you the height. So for this one, they didn't tell us any of the side lengths, they actually told us the diagonals. So they should give you enough information to either do it the way like where you need the base and the height, they'll give you the base and the height. Or if you have to do it the other way, they'll give you the measures of the two diagonals. But either way, you can use that equation to find the area.
Okay, thank you.
Yeah, and then usually it's going to be, so you guys have to, oh, another thing I was going to point out, but all of these equations that we're like talking about, I think it'd be really helpful to memorize them. Because maybe you know like how to find a rhombus using base times height, but then they give you one where they only give you the diagonals and you still need to find the area. So it'd be really helpful to know this equation also. And so what I did when I was preparing for my ACT, just like the math, I like wrote flashcards with a bunch of different equations just so I could like memorize them, and then on the day I just knew them off the top of my head. Okay, so last thing we're going to cover is types of triangles. So this is on page 3 of your math packet, and then it says types of triangles down near the bottom. So I'm going to try and draw them. Okay, so sorry about my bad drawings, but I tried to draw the 3 types of triangles. So the first one is equilateral. And so that one has 3 sides that are all the same length. So I could do those 3 little tick marks. And then another thing about equilateral triangles is that their angles are all the same. And so every single equilateral triangle has an angle measure of 60 degrees. Just because we know the rule where triangles have a sum of 180 degrees. So if we were to divide that into 3, they have to each be 60 degrees. Okay, our second type of triangle is isosceles. And so that's when we have 2 equal sides. And then the third side is a different length. And then we also have 2 equal angles. So the angles or the 2 angles that are equal on an isosceles triangle are going to be the ones down at the bottom here. So basically every angle that, okay, so our 2 congruent sides, where they meet, that's not one of the congruent angles. So the other angles are the ones that are congruent. But where our 2 congruent side lengths meet, that angle is the one that's different. So I'm not going to make up a number because I can't. These 2 angles down at the bottom would be congruent, and then the one at the top would be a different angle measure. Then lastly, we have our scalene triangles. So they've got no equal side lengths and then no equal angles at all. So it's kind of like everything's different about that one. I don't think you need to have the names memorized. They don't ask you about really like vocab, but it is helpful to know these ones and then just to know so we can, if they ask you about finding like angle measures or anything like that, it's helpful to know the different types of triangles. So with our last couple of minutes, we're actually going to go over just some circle basics. So we talked about areas of different shapes, but we didn't actually talk about the area of a circle. So it's kind of on a weird page in the math packet. Okay, so on page 6 in your math packet, and it's kind of just like in the middle of the page, but it's got the 3 equations that we need to know. So it talks about finding the diameter, the circumference, and the area. So let me draw a picture quick and then we'll talk about those. But page 6 in your math packet. Okay. So, say I have my circle here. The 3 terms I just mentioned, but the diameter is the length through the center of the circle, but like from one side to the other side. So this line I drew would be the diameter of a circle. And then the radius this is the diameter. The radius is just from the center to one of the sides. So that would be just like half. But yes, so in your math packet, it writes the equation to find like the diameter of a circle. So if you know the radius, the diameter is 2 times the radius. And then let's say you know, or let's say you're trying to find the radius. It would be just half of the diameter. So if you know the diameter, you can find the radius. If you know the radius, you can find the diameter. And then with circles, they don't call it perimeter, but they call it circumference if we want to know all the length all the way around. So circumference, the equation for that one is 2 times pi times the radius. So let's do a quick example. But let's say that in this circle right here, my radius is equal to 4.5 meters. So if I were to solve for the circumference, I would plug that into my equation. So 2 times pi times 4.5. And then to type that into my calculator, do you guys all know where the pi button is on your calculators? Yeah? Okay. I'll just,
No, they don't. I do because I don't have their calculator.
Never mind.
okay, so I have the TI-84 plus C, so if you have this one, I can tell you where it's at. But if you press the second button, and then it's right under the clear button, it's like a little caret. If you press that one, you should get pi. So you can type that in, pi times 2, and then times 4.5. And then you should get 28. If I round it, I'll round it to the tens place. So 28.3 meters. Yeah, just meters, not meters squared. So circumference is just meters, kind of like how perimeter was just inches or just meters or anything like that. And then we're going to use the same measurements, but if I asked you to find the area of this circle, so the equation for area is, okay, you're up, pi r squared. So it's going to be pi times the radius squared. And then we always have to remember to square the radius before multiplying it by pi, because if we square it after, we're going to get the incorrect answer. So if we use the same circle, radius is 4.5 meters. I'm going to do pi, and then I'm actually going to write my radius in parentheses just so I don't forget. But 4.5 squared, we're going to do that first. And then times pi, you should get 63.6, and then meters squared. You guys agree?
Yep.
Okay, any questions about how to find the area or circumference of a circle? Okay. Well, it's almost your break time, so we're gonna stop there today with the math. But good job today. Did you have any questions about like anything we went over today? No. Okay, so I will figure out and get back to you like the exact breakdown of like the ACT like math. I know they have it out there somewhere, so I'll find it and talk to you guys. But other than that, you are free to go on your break.